All right, so have you ever really looked at a glass of water and thought, there's a philosophical argument right there? It sounds kind of wild, right? But today we're going to dive into the writings of an author named Su Feng. He makes this fascinating case that the unique, life-giving properties of water, well, they might just point towards what he calls a greatest creator. So let's break down how he gets there. So the author really sets the stage with this quote. It's an invitation, you know? He's asking us to adopt a whole new perspective. The core idea here is that if we look really closely at something as totally ordinary as water, we might just be able to see what he calls a supernatural power at work in the universe. And that brings us right to the heart of his work, the big question. Can we actually find evidence of a creator just by looking at water? I mean, something so common? To even begin to answer that, we first got to understand what makes water so incredibly special in the first place. Okay, so the author's whole argument kicks off with the basics, the fundamental properties of water. He has this poetic name for it, the blood of the earth, which is pretty cool. And as we're about to see, he's convinced that its characteristics are, well, anything but random. It all starts super small, right down at the molecular level. The source explains that the H2O molecule is what we call polar. Now, what does that mean? Just think of it like a tiny, tiny magnet with a positive side and a negative side. It's this exact polarity that allows all those little water molecules to link up, kind of like they're holding hands. And that is what gives liquid water its structure and so many of its unique properties. So building on that, the author highlights these 6 key properties. And these really form the foundation of his entire argument. We're talking about everything from it being a universal solvent to the way it handles heat. Each one of these is going to get put under the microscope, so keep them in mind, because the whole point he's making is that none of this is a coincidence. And the sheer scale of it all, it's just staggering. According to the source, we're talking about 326 million cubic miles of water on this planet. It's hard to even wrap your head around that number. And this chart breaks down where it all is. As you can see, a whopping 97% of it is saltwater in the ocean. Now, this is crucial. All of this water operates in what's essentially a perfectly closed system. The author really emphasizes this point. The total amount of water on Earth never ever increases or decreases. It just changes its form and its location, cycling over and over again endlessly. All right, so now we get to the real core of the argument. The author uses this really clever device, a series of thought experiments, basically a sequence of what-ifs. And he uses these to argue that water's super unique properties aren't just some happy accident, but that they're actually intentional. He starts with the most basic things, the stuff we all take for granted. Just think about it. What if the water we absolutely need to survive had a strong color or a taste or a smell? And this comparison really drives the author's point home, doesn't it? He argues that water's neutrality, the fact that it has no color, no taste, no smell, is absolutely essential. I mean, can you imagine a world where every river was bitter or every rainfall smelled, well, just awful? Life would be completely different, and as he suggests, probably not even sustainable. So the argument keeps building with another what if. This time, it focuses on one of water's weirdest physical properties. See, unlike almost every other substance out there, water actually expands when it freezes, and that makes solid ice less dense than liquid water. And this illustrates the consequence brilliantly. What the author suggests is that this one single physical law is what stops our rivers and lakes from turning into solid blocks of ice every single winter. Think about it. Without floating ice, he argues, entire aquatic ecosystems would just collapse. Gone. Next up, the author wants us to think about the specific boiling point of water. We all know it's 100 degrees Celsius, right? But why that exact temperature? Was it just random? So the crucial point here is all about calibration. The author presents that 100-degree mark not as some random number, but as a value that's perfectly suited for our world, a world where we have stable liquid oceans and can, cook our food at normal atmospheric pressures. Okay, next up, chemistry. Water is just incredibly good at dissolving other stuff. It's a property that is absolutely fundamental to all of biology. And this right here really gets to the heart of it. The author's point is that without water's ability to be this amazing universal solvent, the most basic mechanics of life, well, they just wouldn't be possible. Everything from a tree pulling nutrients up from the soil to your own blood carrying oxygen through your veins, none of it would work. So after walking us through all these properties that seem, almost perfectly tuned, the author brings all the threads together. And he poses his ultimate question. Is all of this just one big happy accident? Or is it by design? So let's just do a quick recap of the evidence he's laid out. We've got the physics of floating ice, the chemistry of the universal solvent, its specific boiling point, its total neutrality. The argument is that each of these properties is precisely calibrated for life to exist as we know it. And if you take away just one of them, the author suggests the whole system could come crashing down. And this is where he anticipates a counterargument. He knows someone might say, look, water isn't designed at all. It's just a natural substance that's always been here, period. But here's his rebuttal to that. He argues that, look, science tells us the Earth and the universe had a beginning, right? So it follows that water must have had a beginning too. It wasn't just always here. And if it was formed at some point in time, well, he asks, how did it just happen to get this entire suite of perfect life-sustaining properties all at the same time? This whole line of reasoning leads us directly to the author's final challenge, the big thought he wants to leave us with. And that's the final question he leaves us to ponder. He basically presents a choice. Either this incredible collection of life-giving properties is just the random product of undirected nature, or it's the result of what he calls a careful arrangement. It's a question that's really designed to make you look at a simple glass of water in a completely new light.